Hi, let us read together. Today's book is Calculus Early Transcendentals 8th edition by James Stewart. I want you to focus on page 713. If limit of a sub n as n approaches to infinity does not exist, or if limit of a sub n as n approaches to infinity is not zero, then the series summation of a sub n where n ranges from 1 to infinity is divergent. So once again, the test for divergence simply states that if the limit is not equal to 0, then the series is divergent. So it's easy. All you have to do is to solve for the limit, make sure that it is not 0, and you will know that the series is divergent. So take note of that. It's important. Let's have an example then for us to understand this better. I want you to go to page 714. We have example 10 on that page. So we have this series, summation of n squared over 5n squared plus 4. N ranges from 1 to infinity. Well, that's infinity. You have to show that this series is divergent. So this is the process. The limit of a sub n as n approaches infinity is equal to n squared all over 5n squared plus 4. And then all we have to do is to evaluate the limit. Remember, we are applying here the test for divergence as shown on the previous page. So the details are here. So first, we have to divide both the numerator and denominator by n squared. So you will get 1 all over 5 plus 4n squared, after which we evaluate the limit of the numerator and the denominator. And as we all know, the limit of 1 is 1 as n approaches to infinity. So the limit of a constant is still the constant, so we still have 5 in here. And I want you to refer to page 129 so that you will not forget the theorems on limits. That's how we got 0 for the limit of 1 over n squared. So from this computation, you will know why the limit of a sub n as n approaches to infinity is 1/5, which is definitely not 0. Now that we know that the limit is not 0, we can easily conclude that the series is divergent. So that's easy. Test for divergence. All you have to do is to compute for the limit as n approaches to infinity. Show that the limit is not 0. Once you're done with it, you can conclude that the series is divergent.